The graph of f of x is x minus 1 all squared, take away 4 is shown below. First thing we want to do is sketch the graph of y equals 1 over f of x on the coordinate axes below. I'm going to do it on this set of axes. So every time this is 0, we're going to get an asymptote, because 1 over 0 obviously can't be done. So we'll get asymptotes there and there. Now, it's 1 over f of x, so if this is negative 4, 1 divided by negative 4 is negative a quarter, so that's going to go there. And they'll always meet wherever y is negative 1, because 1 divided by negative 1 is negative 1. So they're going to meet at these 2 points. So what's going to happen is it's going to be very flat here, and then it's going to go down the asymptote. So like this. Now we've got the 2 other limbs to do. Now it's going to meet at 1, because 1 over 1 is also 1, and as this goes to 0, our curve must go off up the asymptote, so it's going to come down like that, and as this goes off to infinity, 1 divided by that is going to go towards 0, and the same sort of thing is going to happen here. So it's going to come down, they're going to meet there, and then it's going to curve and go off along the x-axis as an asymptote. Okay, the next part of the question asks us to sketch y equals f of mod x on the axes below. Again, I'm going to go back and do that on this graph here. So what we're doing this time is y equals f of mod x. Now in this situation we know that anything to the right of the axis stays exactly as it is, and then we get a reflection. So, move that too far over. So it should have a vertex there and an intercept here, and it should go off the top around negative 4. This goes off at about 4. So it's going to come down. Just got to make it look reasonably symmetric. And the key points they'll be looking for is where it leaves the graph and any intercepts, and probably the turning point there. So that would be what they're after there. Okay, so the domain of the function f is restricted to x's less than or equal to k, so that the inverse exists. If this restricted domain represents the largest possible domain, state the value of the constant k. So we want to make the function 1 to 1. Let's just get rid of all my drawing on this. So we're talking about this original function, and we want to restrict it to x is less than or equal to k. Well, if we do that so that we only have this limb, that would be 1 to 1. So the value there is 1. So we'll say k equals 1, and let's just say that f of x is less than or equal to 1 is a 1 to 1 function. Using the restriction that we had in part C, determine the defining rule for the inverse. So let's just try and remember what our function was. It was this. So x minus 1 all squared, take away 4. So we'll say y is equal to x minus 1 all squared, take away 4. And then finding a rule, we always do the same thing. We're going to interchange x and y. So x is equal to y minus 1 all squared, take away 4. And now we want to make y the subject. So y minus 1 all squared is equal to x plus 4. So y minus 1 would be plus or minus the square root of x plus 4. So y is going to be 1 plus or minus the square root of x plus 4. We need to make a decision as to whether it's the plus or the minus. Now, since we went on this side, is that going to make a difference to us? Well, yes it is, because we're wanting to return values in this direction. So we're going to have the inverse function as 1 take away the square root of x plus 4. And the domain for this function would be the same as the range for the original function, which we know was from -4 upwards. So x is greater than or equal to -4.